Alright, so as you can see, there's a little bit of crystal growth on the bottom of the container. My container sits on the back of my desk, completely unbothered. My temperature is set to about 70 degrees, and my light is on most of the day. So this might be contributing to the crystal growth. And then to find theoretical yield, I did this beforehand, but we need to use all four of the equations they gave us in our pre-lab. So we look at the first equation, and then we started out with 0.997 grams of aluminum. We had to convert that to moles, and then based on our stoichiometry, we know that 2 moles of KALOH minus reacts with 1 mole of aluminum to give us 0.074 moles of KALOH4 minus. And then we do the same thing for potassium hydroxide, and we get 0.4 moles. This tells us that our aluminum is our limiting reactant, so this is how many moles of KALOH4 minus we actually produce. And then we use that in the second equation. Using our stoichiometry again, we have 1 mole of aluminum hydroxide and 1 mole of KALOH4 minus, creating 0.07 moles of aluminum hydroxide. And then we have 9 moles of H2SO4, creating 0.225 moles of aluminum hydroxide. So we know that in this case, this is our limiting reagent. So this is how many moles of AlOH3 we have. And then we can use that in our third equation. And we know that it's reacting to form 2 moles of AlOH3 is reacting to form 1 mole of Al2SO43. And that gives us this 0.037 moles of Al2SO43. And then in our fourth equation, we use the same moles we found from the third equation. And using our stoichiometry is a 1-to-1 ratio, so that gives us 0.037 moles of our alum, which is what we're looking for. And then to find theoretical yield, you take that amount of moles, find the molar mass of our alum, which is 474.38 grams. You multiply that by the amount of moles you got, and that gives you 17.53 grams, which is what we expect to get. Our actual yield was 14.25 grams. And then to find percent yield, the formula is actual yield over theoretical yield times 100%. So we took our actual yield of 14.25 grams and divided it by 17.53, multiplied that by 100 to give us a percent yield of 81.29%. Our percent yield was less than 100%, which is expected because most reactions don't go to completion. We could have lost some alum on the sides of the container. Also, when we were conducting our lab, some of the products could have been lost due to evaporation, and we might also have some impurities in our solution, which don't react and would not contribute to our actual yield.